Hi, in this lecture, we will learn more on implicit differentiations. In the previous lecture, we have learned how to differentiate implicitly. And today, in lecture 5, we will learn how to find the gradient of that equation at a certain point. Now, to find the gradient of the curve of this equation, we have to differentiate. But now, when we want to differentiate this equation, we cannot express it as y equal to something. We cannot express it as explicit function. So this is an implicit function, and to solve it, we have to use implicit differentiation. So first, start by writing down d over dx of each of the terms. Differentiate. The first term is in terms of x, and we also want to differentiate with respect to x. So look at my color of highlight. Both are in green color, so this means both are in the same term. So we can just differentiate this as usual. Just bring power 2 to the front, multiply it with 3, you get 6 times x power 1. Next term is 4y squared. So this is in terms of y, but we want to differentiate with respect to x. Both are in different variables, we have to write dy over dx behind it. And then just differentiate 4 times y squared as usual. Bring 2 to the front, multiply with 4, you get 8y. We want to differentiate 15xy with respect to x. So this is a combination of x variable and also y variable. So to solve this, we have to use product rule. Why? Because now we have two functions. The first function is u, 15x. The next function is v, and their relation in the middle is multiplication. That's why we have to use product rule. So write u as your 15x and then v as your y. Differentiate with respect to x. To differentiate 15x with respect to x, both are in the same term, so just differentiate it as usual, you get 15. To differentiate this v function with respect to x, this is not in the same term. So just differentiate y as usual, you get y power 1, bring it to the front, y power 0 is just 1, and then multiply with dy over dx. This is product rule, so remember your crossfish, the fish shape. And then just write down your formula. This is v times u prime. So write v times with the u prime, and then product rule is plus in the middle, plus with 15x u times with the v prime. V prime is dy over dx. And lastly, behind we have 6. 6 is just a constant. A constant, when you differentiate it, you get 0. So it's nothing behind. As in previous lecture, what we will do next is to combine all of the terms which has dy over dx. So now this is our dy over dx term. Just bring all of that to the left side and the rest to the right side. You can immediately factorize it as well. So this will be 8y minus 15x, and then just factorize that dy over dx. After that, bring all of the other terms to the right side. This will be 15y minus with 6x. Next, leave dy over dx as the title, and then divide with the term beside it. So that's the dy over dx term. But now we want to find the gradient at the point 1, 3. So this is not done yet. To find the gradient at the point 1, 3, what we have to do next is to substitute point 1, 3, where the point 1, 3 here refers to a coordinate. So the first number 1 in the front here refers to x, and the next number behind here is y. Remember, our coordinate is in the form of xy. So this means we have to substitute x equal to 1 and y equal to 3 into this dy over dx term. Next, just replace the x with 1 and then the y with value 3. When you press your calculator, you will get 39 over 9. And this is equal to 13 over 3. your final answer must be in the simplified form. So this is the gradient, 13/3, at the point coordinate 1, 3 of this equation. Next example, we have the curve as given passes through the point 1, -1. Determine the value of constant k. So the first question doesn't want you to differentiate, but the second question to be, we want to differentiate at the point 1, -1. So to answer the first question, which is to just find the value of constant k, what we have to do is just using the informations that we have. So what informations do we have here? We have the information about the point's coordinate. So this refers to x equal to 1 and y equal to -1. Now, once we know these two informations and we have this equation, how to find that constant k? What do you think? Well, we already know what is the coordinate at x and what is the coordinate at y. And after we have replacing all of the coordinates into this equation of x and y, what's left is just the constant k. So, the first step to answer question A is just to substitute the value of x and y coordinates into that equation. Now, just replace all of the x with 1 and all of the y with -1. Next is simplify. 1 cubed is 1, -1 power 3 is -1, k times 1 is k, 2 times -1 is -2. Simplify until you find the value of k. Write k as the subject. And you will get your final answer as k equal to 2. Question B wants you to find the value of dy over dx at the point coordinate 1, -1. So this is like finding the gradient at the point 1, -1. So to solve this, we have to find what is dy over dx of this equation. So start by writing down the equation. Don't forget to replace your k with value 2. So this would be 2x. And then just write d over dx in front all of the terms. Why is it d over dx? Because you want to differentiate with respect to x. If you want to differentiate with respect to y, then we have to write d over dy. Next, just differentiate this. Make sure, check your terms. The function that we want to differentiate is in terms of x. And we want to differentiate with respect to x. So this would be 3x squared. Next, behind it, we have y cubed. Check your terms. We want to differentiate with respect to x, but now this is in y term. So differentiate y as usual, you get 3y squared. But don't forget to multiply with dy over dx, because it's not in the same term. If the color of my highlighter is not the same, then you have to write dy over dx, which refers to different variable that we want to differentiate it with. Next term is 2x. You want to differentiate with respect to x. Both are in the same term, so differentiate it, you will get just 2. Next, this is 2y, but we want to differentiate with respect to x. We have different highlighted colors there, so that means we have to have dy over dx behind it, and then just differentiate 2y as usual. This will just be 2. Remember what's your next step? Is to combine all of dy of dx terms to the left side and factorize it. Next, write dy of dx as the title. Are we done yet? Not yet, because we want to find the value of dy of dx at the point 1, -1. Remember, 1, -1 is just a coordinate, so the value in front is just the value of x, and the value behind it is just the value of y. Just substitute your x and y. You will get -1 over 1, and the final answer is -1. Now for example 3, we want to find dy of dx of the equation. Start by writing down the equation, and then write d over dx in front each of the terms. Always check that you are differentiating with respect to what variable. So for this question, we want to differentiate with respect to variable x. The first term is consisting of variable x and also the variable y. It is consisting of two different variables, and the operation in the middle is multiplication. So this is where we have to use product rule. U is the first term y and v is the next term. So write down your u and then your v. To differentiate u, we just have to differentiate with respect to x. Check your terms. This is in terms of y, but we want to differentiate in terms of x. So to differentiate this, just differentiate it as usual. Differentiate y, you get 1, but don't forget to write your dy over dx term behind it. Next, for your function v, this is natural logarithm function. Always remember, before you differentiate natural logarithm function, do simplify by using law of logarithm whenever possible. Do you remember this law of logarithm, which has the form of natural log of a over b is equal to natural log of a minus with natural log of b. Apply that law here. Next, after you applied the law, differentiate it as usual. Differentiate natural logarithm needs to use this formula of differentiating logarithms. Do you remember your formula? To differentiate natural logarithm, the formula is just 1 over the function fx and then multiply with the derivative of that function f. And for v, we have 2 natural log functions. So differentiate it one by one. The first term is natural log of x. So this is just 1 over the function x multiplied with the derivative, which is just 1, and then minus with 1 over the function. Now the function is x minus 1. Differentiate that function, you get 1. Now, this is 2 fractions. You can still simplify your dv over dx term. How to simplify? Just equate your numerator. How to equate your numerator? Just multiply each of the terms with the same variable. So now to equate the numerator, you just have to multiply x with x minus 1 at the numerator and also at the denominator. Also multiply x at the denominator and the numerator of the next function, of the next fraction. And then simplify, and this will be your simplified form of dv over dx. And then don't forget your product rule. The formula is the crossfish sign. The v is natural log of x over x minus 1 multiplied with the u prime, which is dy over dx, plus sign in the middle. After that, the variable y as the u, and multiply it with, now for the next function, this is 2x times y. So we have 2 different variables multiplied together. And we want to differentiate with respect to x. So what we have to do next is just product rule. The u is 2x and the v is y. Differentiate each of these terms with respect to x. Differentiate 2x, you will get 2. Differentiate v with respect to x, you will get dy over dx. Because differentiating y is just 1. Why do I have dy over dx here? Is because we are differentiating with respect to a different variable. And why is it just 2 here? Because we are differentiating with the same variable. Next, draw your crossfish and write down the formula of vu prime plus uv prime. And the last term that we have to differentiate is 3. So 3 is just a constant. When you differentiate it with respect to x, you just get 0. Next step is to combine or factorize the terms which has dy over dx. And then combine these 2 terms. This is just y over 1. So multiply y with the numerator negative 1, multiply 1 with the denominator. Just leave dy over dx on the left side and bring everything else to the right side. For natural log x over x minus 1, you cannot do anything because that's the most simplified form. But now at the numerator, you still can simplify because this is 2y over 1. So to equate the denominator, just multiply with the same denominator, which is x times x minus 1 at the numerator and also at the denominator. Next, we have 3 levels of fractions. So this is just like a over b divided with c, where this is your a, this is your b, this is your c. So a over b is divided with c. So remember, when you divide, you can change it to multiplication, and this is c over 1, and then you just change the position of that c. So we just have to write our a on top, and then just multiply your b with the c term. Now, you can also factorize the y. Factorize y out, and that's your final answer. Now, for example 4, we want to show that if we differentiate with respect to x of the function ln x over ln y, then what you get is the terms on the right side. Start by writing down your left term. Do take note that this is ln a over ln b. You cannot use the law of logarithm, which changes that division to a minus sign. Because now we have two natural logarithms divided with each other. We can only change it to minus sign if we have one natural logarithm, and then you can separate it into two natural logarithms with a minus sign. So this is correct, but this one is wrong. So the only way to differentiate this is by using quotient rule. Because we have two different functions and then the operation in the middle is division, we have to use quotient rule. So write your u as ln x and your v as ln y. Differentiate with respect to x. This one will get 1 over x, and then for v, when you differentiate, you get 1 over y. But remember, this is in terms of a different variable. So you have to multiply with dy over the x behind it. You have to use crossfish with the I in the middle of minus n over b squared, because now we are using quotient rule. This is not product rule, okay? Because it's division. So you have a minus sign in the middle, and then divide with the v and square it. So this just means ln y multiplied with ln y is not equal to ln y squared. Next, to simplify, this is just ln y over 1. So numerator with numerator, multiply denominator with denominator, you get ln y over x, and minus with ln x divide with y, multiply with dy over dx behind it. Always check that we want to show it in this form. So there's no ln y bracket squared below of all of that. So this means we have to divide each of the terms with ln y squared. This simply means the numerator is divided with ln y bracket squared. ln y bracket squared is over 1, so when you change it to multiplication, you have to switch the orders. Now, this just means we have to multiply each of the terms with 1 over ln y squared. Now, you can simplify. Ln y divided with ln y squared, what's left is 1 at the numerator, and then there's nothing left to simplify, and this would be the simplest form. Please check with the one they want to show. The answer they want to show is in this form. Is it the same? It's 1 over x and y. We have the same term in front, and then we have minus ln x over y ln squared, minus ln x over y ln squared, multiply with dy over dx. So we have exactly the same form as the one that we want to show. So that's your final answer, and just stop until there. Okay, thank you for watching.